Hello again. This is the second video in the series where I kind of just want to serialize my knowledge and I go through all of my notes. I take every day, I take 1 to 10 notes, and I've come up to maybe 300, 400, maybe more of these pages, and I need to structure my knowledge, and that is kind of the trigger, persistence and structure of my knowledge. And so I defined my task, and the funny thing is, on the same day, so 5:50 in the morning, I thought I need to go through all my tasks, sum up what each page means, and which is my keyword, great unified theory of philosophy, in order to create a global picture. Because what I wanted to do is, I want to, because when you kind of develop these things over maybe 3 months or 5 months, it's now 18 months that I've been doing it, but kind of the last things kind of maybe 4 months with field theory, quantum field theory coming in and kicking in and so on. So maybe 4 months. And I want to kind of get a global picture in my brain, kind of at once I hold the whole picture in my brain, and define meta principles and describe their relevance by kind of relevance and entanglement. So meta principles are things: how do you think, how is a system composed, and for example, orders of magnitude, borders, that is a principle. So many principles. So I've defined up to now maybe 200, and I need to kind of understand better. Maybe I can even cluster the meta principles. Maybe there's a hierarchy in them. And so in order to grasp the whole thing, I wanted to hold everything I did in the past 4 months in my brain. And I hope I can succeed, because you'll see this is big. So the relevance and entanglement, of these principles, and their order of magnitude borders to structure everything, the universe. I've explained that, I think, in the last video, this order of magnitude border of a system, which I like a lot. And so what I do here with this video, I think there will be something like 10 videos of an hour, so it will be kind of 10 hours. It's very similar to what I did once for 70 books I read. I read, I think a year ago, so like over a period of 1.5 years, I read 70 books. So I then summed them up. I think it was a totally 3 videos, a total of 2 hours. There were 4 central books. I explained what they were about and why I thought they were central. Then I had some 5 supporting books, and then I had some books, maybe like 30 or so, which I called dig deep books, so that on a specific area, digging deeper. And then the third level B was partial entanglement books. So that means they kind of, one book maybe summed up a few of these topics and tried to kind of put them together, or put orders of magnitudes borders in, or said how the entanglement is. So these books. And then obviously the fourth group of books were these motivational books, which the limbic system and the reptile brain likes. So some like easier reads, like a like a novel. Although I didn't read a lot of novels, but so I think after having read so many books, I actually took, for example, Jordan Peterson's 2 brilliant books, Maps of Meaning, and what is the other one? I forgot. They were the most fantastic books, but I just swallowed them. I was so impressed. But it was, I listened to them kind of as they were novels, and they were so clear and fantastic. So I love those. Anyway, and I then obviously, very agile. This morning I thought 5:30. I thought I'll do it. Then I calculated. That's kind of 300 pages I have times 3 minutes. I already saw it's not 3 minutes, it's more like 8 minutes. So I'm a little bit off. So would be 45 hours. That's a lot. And that is why I wrote here also, this is the most sophisticated and realistic or global complete picture a human has ever given. And that is what I really think, because I've never found something as global as this, not deep, as global. And now the thing is, what I explain here further down, is this is deliberately. So what I see myself in in the order of or in the, what is that, inheritance of Leonardo da Vinci or Hegel, who was, as I was told, kind of the last philosopher that thought that he can scientifically solve philosophy. And about 40 years ago, I thought that as well. I thought, but without knowing Hegel, I knew his name, but I didn't know what he was. One of the philosophers, some quotes. But I discovered some years ago that Hegel was actually the one that tried, and then Schopenhauer trying to oppose him, And when I read this, I thought, oh yeah, déjà vu. Yes, I've been there many times. And so I'm kind of, for 40 years, I think that what Hegel wanted to do is doable, and I'll do it. So the result of this video series, which hopefully is not 45 hours, I hope it's less than 30 hours, but anyway, it takes what it takes. So is that externally, which is, if somebody wants to listen to the videos, fine, he can, but it's relatively unstructured material, and it goes very funny. It goes from the back, because it starts with the latest and then goes back into the past. But internally, the result for me should be a complete overview and this will hopefully allow me to structure my knowledge and draw the knowledge picture better. I see this as the knowledge picture. There's this T-shaped knowledge, and then I obviously like the comb-shaped knowledge. And what I want to do is I want to kind of see where the green thing is what I think needs to be known in order to answer the question, what holds the universe together? And so I'm looking in a very structured way, where do I have to, and at what time, and with what impact, and with what tools, thinking tools, I have to increase my know-how to actually get to where I want to be. And as I don't know where I want to be, this is very tricky, and it's an iterational process. But in the end, it's the great unified theory of philosophy of everything. Yeah, most people say everything. I defined it, I think, 20 years ago as global unified theory of philosophy, because I think philosophy is the global philosophy, as Hegel said it, a scientific philosophy, not the philosophy that we have like with these idiotic people that think that they can have an opinion on science. Yeah, great. The French Revolution says we have freedom of speech. Oh yes, and then freedom of claiming idiocratic facts upon science as alternative science. What the? Okay. What did I do on Monday? Trigger. So quantum physics was the trigger. Oh yes, it was very, very funny, because when you look at quantum physics, there's this thing, Schrödinger's cat, which is the minimal quantum system. I think so, but maybe not. Which can decide into plus or minus, or spin up or spin down, so maybe up or down and so on, and creates another quark in the spins in the other direction and so on. So that is 50-50, and we don't know. Yeah, and then there was this thing when you measure it, then it decides, and and that is very funny because when you you have this with people as well, it's funny. It's so it's not now. It's not a. It's only partially scientific. The thing is, when you let's say girl and man, woman man, talk to each other, and you say, I know that you are going to say this. And she will say, no, I'm going to do that. And you say, to the same woman, same situation, you could have said, you would have said, oh, I think you don't like that. Oh, no, I'd like it. So depending on in what mood she's not in love. Yeah, otherwise she would always say yes. But anyway, and here, very funny, so it is influenced by the measurement. So if I measure her, she decides differently. And the intelligence as a transistor, I'll come to that on a different sheet. Now, but also for influenced by the measurement equipment. So I look at the quantum system. So my measurement equipment is part of the quantum system, and it's kind of the same when I have a charge here, negative charge or positive charge here, and then I actually go there with a needle and I measure it, and obviously parts of the current. What is that? Capacity moves over, and then you have a distribution, and the measuring apparatus actually influences the measurement, and you have to consider. You can calculate it and consider how many electrons can be here, and so on. So you could do that. And now the thing is, when you look, this is minimal, the quantum physics, but if you look at the maximum, like a galaxy, here's intelligence. That is why I said intelligence as a transistor. That's a very, very nice thing. That is a very nice thing. When intelligence kind of meets dead matter or splits from dead matter, and then, you have a transistor. That's fantastic. A transistor where the intelligence controls matter. That's fantastic. That's a transistor, but fantastic. But I have more on this. So the maximum is you have, almost the maximum is like you have a galaxy and a star, and the gravitation draws it. I now don't want to talk in the gravitational field, and this is just bending. So I look at it like from a human standpoint. There's a galaxy and a star falls into the galaxy, and this is 100% that it falls in. And here we could also calculate the entanglement orders of magnitude, that we say it could be possible that the star flies away at light speed, something at 50 kilometers an hour, boom, flies away. But the probability is 10 to the power of minus a trillion or something like that. But it will not happen. It's even more, I think, than that. But you could calculate it, what it is. And so that is the kind of the maximum. Here is 50-50, and here is 100%. Yeah? And now the second thought I had, so this was the joke on parallel universes. And the second thought I had, and this is exactly this intelligence as a transistor, will us humans or artificial intelligence, AI, will we succeed in use enough materials, matter, that would be matter, whatever matter is in the end, so to take matter, so sufficient matter to integrate or to use to switch with the intelligence transistor. The intelligence transistor is, I think I mentioned that, when you think I press the button of a nuclear bomb, so that means my finger moves the explosion of a nuclear bomb. So that's a transistor from intelligence, very, very few quants, huge impact. And now, obviously, there was a lot of work before that, and so we have to consider that. Is the work we did, maybe with the intelligence, we can actually, and there is this big question mark I have, whether the second law of thermodynamics can be overcome, and this is exactly this question, can be overcome by this intelligence transistor, so that a thought can switch matter. Yeah, and the thought itself is also quantum field at a very, very hard border by 20 orders of magnitude, maybe 50 orders of magnitude away, so the intelligence from the quantum field, but it is still there. My thought is a quantum field, and so to organize enough matter to be switched with an intelligence transistor, so that this 50-50 quants, which is the normal thing that happens in the universe, do not, play against us, or I now think the 50-50, it was structured. Oh, sorry, I have a different. So that the unintelligent, non-intelligent matter can be changed to behave like it would behave if there would not be intelligence. And so this corresponds that without intelligence, so like random or random future, the random future, or the the non-intelligent future of the universe. So could that be that our intelligence, or intelligence of, in general intelligence, it can be super intelligence, super AI, can it be that we influence, not that it matters because it's billions of years, so what is that? It's something that has nothing to do with humans. We live, if we are lucky, we live 100 years, or maybe if we're really, really, really lucky, we live 200 years. But here we talk about billions years. But it is a theoretical question that I have had for many, many years. So the intelligence transistor switching dead or non-intelligent matter of the universe to influence the way the universe proceeds. Okay. Next thing, I need to speed up a little bit. Okay, I was sitting. That is a funny one. That is, I was sitting on a bank, in the sun, and there was a group, 3 young men walking by, and I was thinking, look, these men, they were laughing and they had fun and they were chatting and going back and chatting. A good group. And I thought, look, there would not be a girl with them. There would not be 1 or 2. There would not be 3 Turkish girls, or it doesn't matter. They were I think Arab, but it doesn't matter. It could have been Germans as well, or French, or whoever, Americans. But the thing is, usually the groups you have these tribal groups, and I thought, so like with the monkeys and so on, and they herd together, the male and the female and so on, and I thought about the women, the female in the evolution. And the evolution, if you draw it, you like 500 million years ago, like the animals grew up, and then you had reptiles, and I don't know whether I get it completely right, reptiles, like, I don't know, 200 dinosaurs, I think, were here 200 million years ago, and then the mammals, I think mammals they are called, when was that, 200 million or was 70 million, I don't know, and then primates, like our ancestors, 2 million years, and then 30,000 years Homo sapiens. Now, none of these living beings, being male, female, being spiders, male being eaten by the bigger female, none of these animals has ever thought, oh, what the fuck? Why am I a spider and why am I male? And why does my partner eat me? So it is as it is, evolution. So, nobody kind of complained about having really bad cards, from nature. Oh, nature gave me bad cards. I'm a female or I'm a male, But then, culture kicked in, and this is in the Bible described self-consciousness. And then you think about whether you actually have pulled the bad card, if life has given you the bad cards, and here, like 10,000 years with the culture was born, maybe that started already like 30,000 years, as we know from the drawings, or so maybe it's even 50,000 years. So culture started, and singing and dancing and sort of movement and all that started maybe already 100,000 years ago, maybe 200,000 years ago. I don't know, but the primates, were like 2 million years ago, and then something started with the male, and we developed very, very fast because of singing and culture and so on. And sounds and enjoying life and so on, and being safe, and being in a group, and being dominating with the fire, dominating the animals and so on. And then somewhat around maybe 30,000 years we discovered who we were, and then I think then people thought about, oh, who are we, and do that. But they still, didn't have like, we can't make slaves, or we shouldn't kill our, a person from my tribe. If I think he's an idiot, I kill him, and there was no punishment and so on. But that maybe started. But they, so here, there was injustice in the system. So when you look at French Revolution, like being equal and so on, equal rights and so on, that is very, very, very young, and they didn't have that. And the woman there was weak, and obviously it was the male, the man that decided, and the woman. And now the interesting thing is, the woman was given by nature all the means to kind of dominate the male. The male was strong, but the woman, the weak woman was able to kind of, do intrigues, to like hide, be nice, lie to him and say, oh yes, I love you, so that he doesn't beat her, or he has, and then, so that is the introduction of, so the woman has her weapons, and the male is strong and has real weapons, and she has the words. And now the big problem that I see in our in our culture that we have, equalitarian culture that we have at the moment, is the guaranteed same level. So that means the woman is the one that has all the biological weapons to dominate the man, to compensate for being weaker, physically weaker. And now she's given the same rights. And that can't work. So we have a shift of equal rights, equality towards the woman. And now, as always, in evolution, what happens is that what happens is two things. One is the man is actually, when he gets married, he is actually in the worst situation, in a non so good situation as the woman, and the consequence is that they fight, and the family is being destroyed. Yeah. So I don't say that is good or bad, but that is what is happening. So the family is kind of not that strong anymore. Okay, maybe the woman took the the burden of keeping the family together. But nature actually invented the woman, that she, if the man comes home and he's a little bit, he's upset and he's, oh, the hunt was bad and I didn't succeed, and he is grumpy, and the woman is the one that then says, oh, everything's fine here, look. Yeah, that's her role, and that's what she usually plays. But now she doesn't play that anymore, and he is told to do not be grumpy and so on. So this doesn't work very, very well. No, this doesn't work very well, because she is designed to fight, but now we say there is no fight anymore. And if we look at the attributes, the man is strong, he's open, and he's honest. The female, from her genetic programming, she is weak, and she is hiding information, and she's not she's not straight. She kind of looks, is that, well, can I say that? Would that help me? Would that not? And so you have these two. Now, one important thing, I draw male and female, yeah, but there are a lot of male that are weak. And the attribute that is important to make this distinction is not whether somebody has a penis and a vagina, but the thing is, if somebody is weak or somebody is strong, and there are a lot of male that are weak, that are really weak, and then they behave also not honest, and they behave, they don't tell you, and they are sneaky and so on, and there are a lot of female that are strong, and say, no, I'm clear, I do this, I'm open, I say what I do, and so on. So it's not attached to the sex, it's attached to whether a person is weak or strong. And now what also happens with this, that the law, all the judges and give the woman the same rights, or even, because she's the weak or she's the poor and so on, give even more rights to the woman. What happens is, as always in nature, that the male walk away from women and say, no, I don't want to have to do with women, because the woman is, she can at any time turn into my opponent, and then the law actually supports her and not me. And so more and more male then say, oh, look, this doesn't work. No, it doesn't work out for me. Now, whether it's good for male, for female, for humanity, I don't want to judge. It's just, it is as it is. There was this. Oh yeah, there was this. I saw this quote from Ferdinand Porsche. I couldn't find the car, or the car I was looking for. For that reason, I built it myself. And my statement is, I couldn't find the solution for the great unified theory of everything. That is why I develop it myself. And that is kind of what I've been doing for 40 years. So I think Ferdinand Porsche was quicker in building his car, great cars, anyway. Oh, yeah, this is... that was very funny. I saw a video. I see a lot of videos from very, very skilled physicians and mathematicians and so on, and I really appreciate how they present the material, and top notch, and you really can sense how they present, because this is one of the things that I don't know, I think I'm very sensitive to that, to read between the lines, how somebody says something that oh, he doesn't know, or here he knows, oh, this is something, no, this doesn't make sense what he says here, or here he's superficial or something like that. I think I can sense that very well. But what happened is, I listened to a professor in Stuttgart, from Stuttgart University, and I thought, what is that? it is the level of a journal, of a journal for everybody, which you could kind of read at the hairdresser. A housewife would read at the hairdresser and say, "Oh, I now understand quantum physics. Wow!" That was that level. And then there was the comments. That was the worst thing. There was comments under that video. "Oh, great! Thank you so much for this." And I thought, but that was. I would bore a physics class from 10th grade physics class. And so I had this thought. I don't know why, but it is something that reminded me, if somebody wants to use a little soldering gun for electronics to build a container ship, even if you would have 100,000 years, he couldn't do it because the tool is not hot enough. No, 400 degrees, and you have to melt. You have to melt steel, and at I don't know 1,400 degrees Fahrenheit. So terrible. That was I thought this cannot be. How. And not even, sometimes you listen to somebody giving a speech, and he's talking to, I don't know, he's talking to housewives and workers and so on, and they are not interested in quantum physics. But, because he understands quantum physics, he then can abstract it in a way so that it is the model he presents is two things: understandable for even the ones that are not skilled, but still not very far off from what it is in reality. And that professor was terrible. Okay, here this was I defined in a former video just of the series the complex level of complexity, and there was. Jean Carroll, which I really adore. I really think he's spot on, fantastic. The depth in knowledge and math and physics, and stunning. But he had a guest, and he with him with his mathematical definition, this professor's mathematical definition of complexity, which I liked a lot. Some parts of it, like the complexity of finding, for example, if somebody gives you the first 100 numbers of the number pi, and says, "What is this?" and you didn't know that it was the number pi, would you find it? And then somebody could say, "Well, it starts with 3.1.4.1.5. Okay, that is pi." And now the thing is, what if somebody would present you a number 100 to 200, and then what would you say then, with these 101 numbers? What would you say then? Would you find it? And now he defined that as complexity, which I found very, very funny. That is funny. That is a nice thing. And he then calculated the complexity and blah blah blah. But I think what I always like to do is, while he was looking for a mathematical measure of complexity, what I like is this, first of all, orders of magnitude thing. And for me, complexity, there is this thing like NP, I think it's NP complete in computer science. There are some problems that are linear, that are quadratic and exponential, and then NP complete. Yeah, and I think that's all. I don't know, that was like 30 years ago. So, but the principle is you have those, and then maybe you succeed in getting the experiment a little bit down, and the NP complete are always some that go through the roof, no matter what you try. And so you need to reduce those, or you can use a quantum computer for some problems once they are there, to solve some things. But okay, so we have those, and that's it. And so I tried to say, what is the minimal complexity? And I thought maybe it's 1 equals 1, tautology. It is as it is, like this. This may be the minimal complexity. In a quantum system, it's maybe if a quant goes up and then, so it's up, down, and then it goes down, up, and then it's the same again. So maybe it's something like dark matter, just in the vacuum state, it just does nothing. So that is maybe the minimal complexity, because we just know what it does for the next billion years, nothing. And then the highest complexity is what I say, the universe. Yeah, the universe on quantum level. That was the complex, because I had that written, what it means. And obviously, our universe is structured. And the structured is by introduction of orders of magnitude. So some systems are contained, and because the orders of magnitude are 2, 3, 4, 5, 10, 100 between those systems. And now the thing is to find a structure, simulate the structure, and then in every structure, depending on the model granularity, simulate every of these models, and the results calculate with a delta analysis to understand how precisely you simulate the thing. That is a complexity. That blows your mind. And I think I was looking for the highest complexity. And then you could even say, and then build a computer that does that. Something like that, but in terms of complexity. And I think what I want to do here is like in the I think the film was called War Game, where the computer took over the atomic bombs, and these little kids invite the little one to play tic-tac-toe, and the computer understood that in a game he can't win, tic-tac-toe he can't win, and he then said, the computer said, I cannot win a nuclear war. So he discovered that. And so it is, that's, so the complexity, we shouldn't ask that question. And that's exactly what I wrote here. It depends on our question. What is our question onto the universe? Do we really want to know? For example, I asked the quantum field, and we know that there is no free will, and so and that all the things behave like this and this and this. And then I ask, will that lady that I like here, that I see on the table next to mine, when I ask her to marry me, will she say yes, or slap me in the face? So could I simulate that on a quantum field level? No, I can't. But why should I? And who cares? So so the question sets the complexity. Yeah. And so when I look at this is a quantum field. This is the whole universe, the quantum field. And we don't know what the underlying things are. We don't know. That is what Einstein wanted to find. And when they go to CERN, and have things collide and then film it and try to find bosons and leptons and gluons and so on. So that is what they do. And once we have that, I think we are done. Sorry, we are not done. We will never be done. But then we could at least say, and finally we know what holds the universe together. I make a question mark whether we achieve that. But I hope that will solve this. But yes. Okay, that's what holds the universe together on a very tiny level. But the thing is, I now want to simulate what the universe does, based on this knowledge and then based on the structure it has. So what is the structure, for example, a galaxy or a star or a moon or then underlying dark matter, all these things. Then the clusters, could we say gravitation, so the field itself, the gravitation, what is the curved space? I don't know. What are the clusters? That would be a logical cluster, because it's everywhere. So, but it is an underlying cluster. And then how related are things to it? So when a gravitational wave goes through, how does it affect this? What is when electromagnetic goes through? That is the kind of the level of entanglement between these different clusters. And then how many clusters do you need? Yeah, how many clusters do you need? And then I had that in the last video. And then how brilliant how big does our brain have to be to understand? I wrote here Earth and I crossed it out, the universe. Understand the universe. Because understanding the Earth is pretty easy. Oh, and then, wow, here. Exactly. So that is feeling. Yeah, exactly. So I wanted to understand how much yeah, exactly. So the central question is, can I structure the universe, so the quantum field representation of the universe, or a quantum field of the universe, can this universe be sufficiently well divided so that the 10 to the power 100, kind of 10 to the power of 9 associations, we have 100 to the power of 9 neurons. So let's say 10 to the power of 9 or 10 to the power of 8, doesn't matter. Can these kind of brain cells, which are already clustered, to keep associations in them? So it's not one brain cell, but it's can hold a name. Yeah. So in the brain, can it grasp the universe? So that means, can we divide and conquer the structure of the universe in a way that the human brain can grasp it in one go and make sense of it? Yeah, that is, so divide and conquer we have to do, and so that is, and what I have here is this, this divide and conquer is being done by orders of magnitude. Between a planet and space, there is some order of magnitude division between it. Between, for example, a gene and a cell, a gene in a sperm plus an egg, and they form a baby, and then the baby separates from the woman, from the womb, and then you have then division lines, and then we introduce, and that's so interesting, because when is the division between the different systems? Is that in a second? Is that a linear function when you have this division where you spawn out a different system, which then has created these orders of magnitude divisions between. Orders of magnitude between means the influence, for example, the air has to the skin and the body is a division. So, or even a cell, which we can say this is a cell and it has a shell around it, a skin around it, and then, or membrane, or whatever you call it, and then that is kind of, it is entangled with its surrounding, but it still has a division, and we can, so it has a structure, and so that is important, these. But watch out for one big thing, and that is the dynamic. The dynamic kills everything. It blows your complexity. I think I had that in the video, last video. The dynamic, which means let's play it for 100 hours, 100 years. Let's play it for 100 years. That's it. The complexity of even the smallest control system. Forget it. You cannot predict anything if there is a small uncertainty into it. That's it. So Okay, that seems to be for me quite obvious, this thing here. We are at 44 minutes, so I'll go for some other day. So 5:30 on a Monday. Yeah, this is the initial thing on the complexity. So the really interesting question regarding complexity is, from what level on can humans not understand it anymore? So somebody explains a system to you and you cannot understand it. So the divide and conquer doesn't work. So somebody gives you like draws a picture and says this is the system, and you say, ooh, I don't know where do I, oh, everything is entangled, and not division by order of magnitude, but division like, yes, that has an influence of 8% and is an influence of 10%, and there's a function of the, and yeah, but that means I need to put all these 100 components together, yes, and then oh, and the clock, yeah, it's like every millisecond, okay, and how to, and then you say I cannot grasp, I cannot understand what this system, like for example the metabolism of the human, forget it, you cannot divide and conquer it, because it's not it's dividable, but the influence, the division is not by orders of magnitude, where you can say, look, this doesn't influence the other thing a lot, so we can actually divide and conquer. So what system cannot be divided and conquered? So how many parallel associations are necessary to think in a system? Like Einstein was able to think in the curved space time continuum. Mozart was able to think in music. And so how many parallel associations do you need? And well, here's the often mentioned order of magnitude border of a system. And yeah, and the orders of magnitude borders, for example, are here metal, and when I can be a solid metal, I can melt it, or can have a metal gas, and so they would most probably have order of magnitude borders between themselves, and yeah, so and so this is kind of a house with concrete, and there's the air, and so we can divide and conquer here. We can divide and conquer, but if we have a quantum field, and at a quantum field level, we could also, we could kind of define what it means at a quantum field level, the division between the house, concrete, and the gas. We could define that at a quantum field level. A question mark. I don't know how far we are in that. But now the question is, does that help us? So in one system, the divide and conquer works well, but the question is, would it also work as a division if I look from the level of, very fine level of quantum field? I don't know. This would be a thing that I might step over in some months or so. Okay, what? Oh yeah, I had a long walk. I think 7-hour walk, 30 kilometers, and I thought a lot. But I hadn't taken any electronics, nothing with me, not to write down, so I had to remember the things I was thinking. So I had a funny thought, which is, in German, probably in English I can't find the word for it. You have when you influence somebody, you tell somebody, you're there, and you influences somebody slowly, and you build up some some behavior in the other person, and then, or some thought in the other person, and then after, let's say, you build up for a year that, and then a spark, just one statement, starts the revolution in that brain or in a country. So there's always two periods, when you have to prepare, the period of preparation of an environment, and then you need a spark. So you have this, and I have this for Corona. Like there was this build up, so kind of they built up the mindset, the media, they built up everything, and then they just needed a spark, and bam, and it fired, and wow. And now, very, very interesting. I thought I created a new word which I liked a lot. That was based on the video from Jean with with. I had another example here. Maybe I wrote that. Yeah, but here I have no. I wrote down the sample from Jean. It is this 100 numbers, 100 digits of pi. So from 100 to 199. And so if you put that into Google, maybe they find it, but I don't know. Maybe they find it, but some of the things, let's say you have these reversed, so they are reversed, from 100 to, it's not from 100 to 199, but it's from 199 to 100, and somebody gives you these numbers, and then Google wouldn't find it, I think. So that means here you have to do an intelligent research, and I called it to Sherlocken in German, and in English it would be to Sherlock or to Holmes. So it would be intelligent Google. So it would be a two-step approach to Google. Yeah, Google finds you, I don't know, you need a keyword and then you find it, but first you need to find the keyword. And so it's an intelligent search, so it's a kind of a mix between human intelligence and then the search engine. And so I think that is often required. And obviously we sometimes do that, we alter our search criteria and so, but I have to say it's often a try and error, it's a try this, and then, oh, look, here is something 15th point, here this, the 15th hit, oh, this is it. And so it's a try and error. But the word here, Sherlocken, to Sherlock, is from Sherlock Holmes, and means I put a lot of intelligence in to then design the research. So that was what I thought about. And then I had another thing, and when intelligence is being brought into matter, and here the experiment was, you have a sound wave, the quantum field of a sound wave, and then that quantum field of the sound wave hits the matter in the ear, and then it goes into, through the material into the, and there's brain, I think there's a syllable recognizer that recognizes the syllable, and that is calculated. It's what is that? It's context sensitive language in the because it has to remember, and then the meme. So it's a kind of a meme thingy, which then recognizes the syllable, and then it says to, so, and I called this was the word I created here, the plusware instead of hardware. It's plusware because plusware. Why? Because it's plasticity of the brain. You can actually learn, which I like a lot, because you actually learn. The baby learns, and then when you're 7 or 8, this neural network is done. It doesn't learn more syllables. So that's the plusware. Normally, our brain is plusware for all our lives, but and our ear, the syllable recognizer is maybe also, but not very much. So at the age of 7, 8, it's gone. That's it. And then it gives a syllable to the brain. Now, where's the intelligence? Now, this when there's just sound, like just what is that? Random sound, noise, random noise. There's random noise generators. Give that in, so there's no information in it. But if there is, like with a sentence, if I speak a sentence, then there is intelligence in the sentence, and then the quantum field getting in here has been generated by something intelligent, so it's already intelligent. So already that quantum field is at a specific level of at a model at a specific granularity is already intelligent. So it hits the ear. So that means it's not that an unintelligent sound hits the brain, the ear, and then the brain makes something out of it. No. It's the whole thing. The generator and the receiver is already intelligent, and that means that the intelligence has been kind of evolutionary. So it's always both sides that have to. So, and I have another big sheet on. I think I even wrote a comment on YouTube on the evolutionary development of intelligence, where intelligence was introduced. And then I had the fourth idea on that hike, long hike, 7-hour hike. I had the biological transistor. Yeah, and so it is a small part, very small weight or quantum field or whatever at what level you want to call it, a thought, does something and moves a car or whatever. Yeah, so that means it's a biological transistor. And there, this is one of a field where research the biological, because it is that a biological transistor has actually 3 states, and I hope I go this, yeah, exactly, here, and which is a fight, flight, and freeze. And fight and flight is active, and freeze is passive. And then this was the thought. That's why there's an exclamation mark. Attack pushes the other, so it is a push. It says, I push you, and it's even at the cell level here. So animal and attack, or human attack and flee, and flight. Yes, but it's also on a cell level. On a cell level, it means that there is I do it. So attack means I push the other. So the next cell, the opponent, the whatever, I put a weapon, I push. And flight is I move away and the other comes. The other comes. So the other attacks. So I flee, the other runs after me. So the one is, so both are active. So attack and fleeing is active, but the one pushes the other and the other pulls the other. Yeah, and then obviously the third one is the passive one, which is the freeze. I don't do anything, and the other decides. Yeah, so it gives the ball completely to that person. And then number 5, what is actually switching? I haven't researched this a lot. What is actually switching the transistor? This the biological transistor. So what is being switched? What goes in, what comes out. I have to research that. I haven't done that. Okay, that's it. We are at 1 hour, and the battery is almost exhausted. I'm also exhausted. That was good. I like that. I saw that there were some things that I need to still work on, especially here. What is it that this transistor, this biological transistor, switches? Okay, that's it. Thanks for listening. 1 hour. I'm very happy that I did this, but there's so much to do that will never end. Okay, thank you very much. Bye-bye.